The average height of males in the U.S. 69 inches, standard deviation of 2.5. They said this is known to be normally distributed. Complete the bell curve in all 7 positions. So when you make your normal curve, so they say that this is 69, and then I add 2.5 to that. So 71.5 is here, and then 74 is there, and then 76.5 is there. Okay, and then if I go the other way, we'll do this in red. I'm subtracting. So 66.5, and then minus 2.5. 64 minus 2.5, so 61.5. Okay, now before I go much further than this, I want to flip back and I want to fill out all of the categories for the percentages. All right, so I'm going to hand you a blank normal curve. The only thing I want you to write on this normal curve is I want you to fill in whatever notes you need on this normal curve. This would be a good thing for notes. Don't base it on our height problem. We're going to base it off that picture, okay? Okay, so this would be just something that you could quickly. Oh, I didn't take a roll yet, did I? Okay. I had to take a roll. There you go. All right. Okay. No way. All right. So what I think on that normal curve that I gave you, write in as neatly as you can this information on that normal sheet so you can access it. And again, if you went and Googled this, sometimes you might find ones that are a little tiny bit off, and that's okay. For the most part, you're safe to stick with this information as far as that goes. So this is basically the normal curve based on our problem about the heights, okay? And this is where you're going to start counting stuff up. Okay, so I'm going to go back to the homework assignment. So that is the first thing. That's the normal curve with all the things in there. You don't have to have the percents in there, but I want to make sure on that normal curve paper I gave you, you put in all these percents. Okay, because that'll be useful for you. You realize this is the average right in the middle. Add 1 standard deviation, add 2 standard, add 3, minus 1, minus 2, minus 3 standard deviations, so on and so forth. That's how it works. Okay, so that'll be useful for us on these test problems. So then it says problem number 2. What is the chance that you have somebody who is taller than 74 inches? This is for number 2. Okay? So what we can do up here is one of two things. I can add up the 0.15, 13.5, 34, 34, 13.5. You can do that. Or you realize the entire area is 100%. So you can go 2.35 plus 0.15 is 2.50. 100 minus 2.50 is 97.5. Okay. So we want to see, and this was taller, right? So if it's taller, I'm going to look at these two numbers here, add them together, 2.35 plus 0.15. So you have a 2.5% chance that if you were to pick a random person out of the population that's male, that's an adult male, you have a 2.5% chance that you're going to find that person. That's taller than 74. Okay? And then the next one says, what about somebody who is what percent of the U.S. males are shorter than 66.5? So this right here is problem number 2, and we want shorter this way. Okay? So shorter than 66.5. Hello. So shorter than the 66.5. So talk to me how I'm going to do it. This, I gave everyone one of these. So fancy, I know. If you write like those percents in there and whatever notes, that'll be something that'd be a total go-to for the test or the quiz. All right. So friends, how would I find out if someone's shorter than that? 0.15% plus 2.35%. Plus 13.5%. So 2.5, 14. Is that 16%? Okay, so the chance that you were to walk out in society and select a male randomly, the chance that you find a male that is shorter than 66.5 inches is a 16% chance. Okay? And then number 4, what percent of U.S. adults, males, are between 65 and 74? Okay, between 65 and 74. 65 to 74. Okay, so this is basically number 3, which is going to be 34 plus 34 plus 13.5. So 68 plus 13.5. Oops, clear. 64 plus 13.5. So this is a 77.5% chance. Again, if you were to walk out in public and select a random male, adult male, you have a 77.5% chance that you find somebody that's between 66.5 inches and 74 inches tall. Okay? And then what percent of U.S. males are taller than 76.5? So this right here, 76.5 and taller. So this is just going to be a 0.15% chance. So again, if you were to walk out in society and you were to randomly select a male, an adult male, you have a 0.15% chance that you come across somebody who is 76.5 inches or taller. Okay? All right. If Nathan is taller than 86% of the U.S. male population, how tall is he? All right. So there's a couple of ways that we could start playing around with this. Okay? So it says that Nathan is supposedly 86% in height. So what we're going to do is, I know the z-score is observed minus mean over the standard deviation. Okay? So let's see. 86 is going to be our z-score. We're not really using a z-score. Actually, I'm not going to do that. I'm going to do the other way. I'm going to say that it's, I don't want to do this. Observed minus my average. My average is 69. Divided by the standard deviation. 86 minus 69 divided by 2.5. So this is going to be a z-score of 6.8. Okay? 6.8 standard deviations above. Okay? So
So, hang on, I did this wrong. I'm crossing this off. Shh, I made a mistake. I need to look at my notes. I forgot how to do this problem. I failed you all. Sorry, guys. Let's go back here. 100 minus 2.35 minus 0.15 minus 13.5. Okay. All right.
I found the error. Yes, we have a wrong number written. So this 86, we're needing to change to an 84. So change this to an 84%. I made a mistake. There's my mistake. All right. So we can simply figure this out pretty easily. Okay? It says, so change that 86 to an 84. Okay? So basically 100 minus 84 is 16%, right? So then we have to figure out, okay, he's going to be taller than this, and probably this. Okay, so if I add those together, if I go 0.15 plus 2.35 plus 13.5, if I add these three numbers together, this gets me 16%, which means when you make that correction to 84%, 16 plus 84 is 100%. So if this person is taller than 84% of the other people of males, he is 71.5 inches tall. So you have to work backwards. So I apologize that we kind of goofed that up. All right. Number 7. Hey, when did I say our quiz was? Thursday, right? Thursday. I'm going to move it to Thursday. Yep. Is that okay? Okay. All right. All right. So IQ tests are designed to be normally distributed with a mean of 100, standard deviation of 15. Complete a bell curve with all 7 positions. Okay. So for this particular problem, if we were to create our normal distribution for IQs, so this is 100, 115, 130, 145, 85, 70, 55. And then I need to fill out my stuff. So this is 0.15%. This is 2.35. This one is 34. How much was this one? 13.5? 34. 13.5. 2.35. And 0.15. Okay. So that's our all 7 positions as far as IQ scores go. Everyone's good with how I add 15, 15, 15 or subtract 15, 15, 15? All right. So number 8 says, what percent of people have an IQ greater than 145? You're talking about 0.15% of the population. So that's the answer to number 8. Okay? And then all IQs between 85 and 115. So that's these. So that's going to give me 68% of our population falls within 1 standard deviation. So that's the answer to number 9.
And then if you have an IQ that is one standard deviation below the mean, so this is one standard deviation below the mean. So you have an 85 IQ if you're one standard deviation below the mean. Okay, and they've actually collected a lot of data on IQ tests. I can't tell you the percent of population that's given it, but it is pretty fairly normal distributed. All right. Following activity asks you to investigate a date set for normality. The data is set below. Okay, so this is one that we definitely want to plug into Desmos. And when we plug it into Desmos, then we can start taking a look if it has normal distribution or not. Here's my keypad. All right. So this is the length of randomly selected professional boxing matches in minutes. Ooh, I like boxing. All right. Ooh, you guys are looking at that. Desmos. Now you got to see. All right, here we go. Desmos. Making a table, one variable statistics. I have 17.2 minutes, 15.2.
Not on the table, sir.
Oh, thanks for looking out for me. All right, 17.2. Will someone read those to me?
Yeah.
Go ahead.
17.2. Oh, wait. Which one? Oh, yeah. Oh, no.
It doesn't matter.
Yeah. 16.3.
16.3.
14.9.
14.9.
2.5.
2.5. Holy cow.
That might be not right. 19.3.
19.3.
7.6.
7.6.
11.2.
11.2.
28.4.
28.4.
15.3.
15.3.
17.2.
17.2.
9.
9.
15.2.
15.2.
14.9.
14.9.
11.6.
11.6.
12.5.
12.5.
15.2.
15.2.
8.5.
8.5.
16.3.
16.3.
17.3.
17.3.
10.6.
10.6.
11.5.
11.5.
15.2.
15.2. That it?
Yeah.
Thank you. All right. So we have our data. And the first thing it says, use your calculator to find the mean and the standard deviation. So I can do mean parentheses x1, and I can go STDEV x1. So it finds us our mean and our standard deviation. Okay? So 13.99. So we're going to call it 14 and 5.1. Did I write that down right? 5.1. All right. So we can, mean and standard deviation, that works. If we draw out our 7 positions, our mean is in the middle. Realize I rounded my 13.99 to 14. Okay, or you can say 14.0. That way we know we rounded. Okay, and so one standard deviation, that's 19.1. That's 24.2. And one more is 29.3. And then going the other way, 14, oops, come on, baby. 14 minus 5.1, 8.9. Minus 5.1, 3.8. Minus 5.1. Negative 1.3. Ooh, you have a boxing match that's negative in length. All right, which can't happen. So over here, this is 0.15%. This is 2.35%. This is 13.5. This is 34, 34. These are all percents. I'm just being lazy and not writing a percent sign because it's so difficult for me to write those. Okay, so that's our breakdown. Yeah.
I don't think it wants us to use those
Oh, we don't have to use them?
Well, we shouldn't because it's not on a normal distribution.
Oh, it says it's not?
Yeah, it wants us to figure out.
Oh, okay. Use your calculator, mean standard deviation, one variable set, sketch the normal distribution with all 7 positions labeled, okay? And then,
Says do not use the 62 by 9.7.
oh, okay. Do not use the 6895 to answer these. What percent of data above lie within 1 standard deviation of the mean? Okay, so it's fine that we have the table drawn. It's fine that we have the percents. Now, I just added more information we needed. So to get to number 13, so what data lie within 1 standard deviation? So 1 standard deviation, okay? So we're going to go between 8.9 and 19.1. 8.9 and 19.1. Okay, so 8.9, 19.1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 17 pieces of data. Congrats, buddy. Still walking on sunshine?
Oh, yeah.
All right. So, how many did I count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 17 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 17 out of 22. 17 divided by 22 is something. 17 divided by 22. So this comes out to 77.3%. Okay? 1 standard deviation should have been at 68. Is 77.3 68? Throw up, we don't think so. Okay, good. All right. What percent of the data lie within 2 standard deviations of the mean? So 2 standard deviations. Okay? So we're not answering 95%. So we're going from 3.8 to 24.2. So 3.8 to 24.2. 3.8 to 24.2. All right. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 out of 22. This was supposed to be 95%, but if I go 20 divided by 22, we get to 90.9%. Okay? Is 90.9% the same thing as 95? No. Okay? And then what percent lie within 3 standard deviations? So 3 standard deviations of the mean. So we're going from negative 1.3 to 29.3. Is there anything that is going to work? That's going to work. So this is 22 out of 22, which is 100%. Is 100% the same thing as 99.7? The answer is no. So obviously, just by looking at this, we can verify this is not a normal distribution based on the information. And then number 16 says, from the information above, is this normal distribution? So this fails. This fails. This fails. Okay? We have 3 major things right there that make this fail, say it's not a normal distribution. Other things that we could have done on this to verify, and it didn't ask us to do, I just want to make sure we feel comfortable with it, is I could have found the median of x1. And my median was 15.5. Okay? If it's normal distribution, the mean and the median have to be the same. 13.98 or 14.0 rounded to is not the same thing as 15.05. So there's a whole lot of information that doesn't work. I mean, you could sit there and say, okay, well, I still don't believe it. You can go histogram of x1 and look at our data. We've got to
change the size, maybe make them 5s. No, make them 4s. 1, 2, 3, 4, 5. Yeah, right there, that's showing a skew right real quick. Okay? I mean, you could even say, can we verify with a box plot? Our box plot of X1. And let's get rid of the histogram. Boom. It's showing that that's taking place as well. All of these things are all verifying that we don't have a normal distribution. So we have lots and lots of evidence. And my friends, I kid you not, and I know it sounds kind of silly, but why do people care whether something's a normal distribution or not? So honestly, so let's say I came up with a new battery for a cell phone. If I can create you a battery that lasts 7 days on your cell phone of continuous use, are you interested in this? No, I'm just saying, like, but if you could find something that could fit in your cell phone that's going to last 7 days of continuous use on your cell phone, are you interested in that?
Yes.
Now, so let's say you have someone who developed it, you're like, I got this developed. Now they go and they run all of these tests. I mean, do you all realize that majority of the ads that you see on, do you guys get ads on, I know on Facebook, but I'm old ladies Facebook. There's ads on Facebook. Are there ads on Instagram?
Yeah.
Okay. Now you might see an ad saying, hey, buy gold. Okay? Yeah, don't. It's not a good idea. People are like, oh yeah, but you have to understand the price of gold. No, what I understand for the price of gold is the price of gold has not stayed up with the price of inflation. And if the price of gold did stay up with the price of inflation, the price of gold would be about $11,000 an ounce versus $2,000 an ounce. It's a bad investment. But these are all things that you get that guy who says, hey, I developed a battery to put in your iPhone or whatever phone you have that's going to last 7 days of continuous use. In fact, it actually quick charges within 5 minutes. You can go from 0 to 100% in 5 minutes. You're like, this is the greatest battery I've ever heard of. I want this battery. But they might market to you on some Instagram thing. So let me ask you this. If you saw an ad like that on Instagram for a battery that's going to last 7 days of continuous use on your phone, charges 5 minutes, are you more or less likely to click on it? I mean, I think a 7-day battery, 5-minute charge, I think I'm gonna be able to get a whole lot of people in your generation to click on my ad. And I'm gonna make it real convenient. I'm gonna break this down into a monthly payment of $3.45 a month, and my very small print at the very bottom will say 300 month minimum. So now you're committed to this payment for 300 months. And you're like, 300 months? I can't even do that math in my head. They do that on purpose. So then you're sitting there, you're going, I got this battery, and it barely lasts, an hour. This thing's a pile of crap. And so you post on, your social media, hey, this is junk, this doesn't work. Well, the company realizes you just, thrown out a Yelp review on them. So they're going to try and correct it, make you feel better, or just shut you up. They'll say, hey, we'll give you a lifetime supply of these batteries if you retract your statement. Okay? Well, then the company goes bankrupt. But basically, all of these tests on statistics, they didn't work. But we fall for advertising. We fall for advertising all the time, my friends. And it's unfortunate because it's like, oh my gosh, that's an incredible deal. Okay? McDonald's now has the $5 meal deal, right? How big is that thing of French fries you're going to get? Oh, there's about 7 in there. I know McDonald's, man, I do 7 French fries per mouthful. It's like, wow. That's gone. Okay, but it draws you in. So do you want to be the consumer that is literate, or you want to be the illiterate consumer that goes and does anything? I would say you want to be literate.
Do we all fall for an occasional thing? Sure. Okay, but if it's a small monetary amount of money, we're not going to worry too much about it. If it's like, holy cow, we're giving up life savings, you got to be careful. Friends, I will tell you this, and I just need you to keep an eye out on it. Do any of you have grandparents who now have an iPhone and they like to send you the emojis that they find?
Yeah.
And you're like, oh, great. I've been using that since fourth grade, right? Like my wife's father, he thinks it is so funny to send the poop emoji. He thinks that's the greatest thing in the world. He's like, oh, look what I discovered. He's like, you got too much on there. Like, I'm sorry, friends. I don't think people at my age and older should have an iPhone. I'm going back to a flip phone. I'm going back to the one that actually ergonomically fits in my hand so I don't drop it because I'm getting older. But, I mean, people fall for cons all the time. So the cons I want you to be literate of. Act now. This won't last more than an hour. This is the last one we have in stock. You know, if you don't act right now, you don't get this price. These are all things that you say, well, I don't need it, and you walk away. Okay? There have been all kinds of stuff, things that have come out there. I'm not the best person in the world to go buy cars because I know a car that I would like. I actually look up how much it costs to manufacture the car. I also wait until late in the month and I find that car and I walk into a car dealership and says, here's a check for that car right there. It's already written out. The dealerships will either say, that's not enough, we don't want it. And I say, fine, I'll walk away. Or they'll be like, are you sure? Yeah. Meaning my last car that I bought, I wrote down a check for $27,300. So here's the check for $27,300 for that car right there. That I don't think we can accept that. Okay, fine. I'll go down the road and I'll find the exact same car. I'll make them the same offer. You watch a car dealership. You put a viable value out there that's far less than what they're asking. They'll bite. If they're desperate for that sale, they'll bite. If that car salesman says, okay, so I don't get a full commission on this, but it's only going to take me 20 minutes to make $500, they're going to jump on it. Okay? So be a knowledgeable consumer. You know, I'm not saying everything you come across, you make sure it's a normal distribution, but it's okay if you call people on their grief. Is it normal distribution or not? It appears to be. Well, did it pass the 68, 95, 99, 7 rule? Did it pass mean and median rule? Did it pass, did my histogram look like this? I mean, be knowledgeable. If you are a knowledgeable buyer in the market, life is fine. Yes, there are road bumps, but life is fine. So, friends, what I would like us to glance at between today and tomorrow is that, whoops, get rid of all my dots and stuff. Let's have you work on 3.1 to 3.3. We'll make sure we go over that in its entirety tomorrow. So then when you have your quiz on Thursday, blocks, I gave this to everybody. So this is just normal distribution, which you can find it. I didn't give you one. Did I give you guys one? Sorry. So on page 71, Watts, is the breakdown of the percents, which will help you. Yeah, did I not give you one? Oh.
Did you do what?